Good morning, good afternoon, students.
Good afternoon, ma'am.
Okay. Good afternoon. Can you see the screen?
Yes, ma'am.
So we were seeing, we have in previous lecture we have seen variation of parameter formula, and based on that we were solving example. So I told you to calculate phi inverse of t. So whether you got this phi inverse of t, 1 upon determinant of phi t into adjoint of t. Anybody got this answer? Whether you checked it? Are you there? Students, are you there? Can you hear me? Anjali, Amruta, Priyanka, are you there? Dipti, can you hear me?
Yes, ma'am.
Yeah, so I'm asking question. Whether you checked whether phi inverse of t you are getting that one. Or shall I show? I'm asking whether you got it or I have to solve it. Why you people are not replying to me? ऐश्वर्या सावंत, प्रियंका वैद्य, क्षीरसागर अमृता. Please reply me. If you are not replying, there is no use of live lecture. I will just record it and I will upload it. You can see anytime you want. Why I am taking live? Because your queries will be solved here itself. If you don't want to answer or if you don't want to live, then no need of live lecture. I will just record it and I will upload it. What is the problem? Mohammed,
Yes, ma'am.
what is the problem I am asking?
No problem, but I try in this, but no answer.
You got it?
Yes.
You got it or not? Did you got that phi inverse of t?
Ma'am, I try, but
Yeah,
I don't
it's
know.
okay. If you not got, I will take this. But I am just asking whether you tried it. I am asking question to everyone, but nobody is replying. What is the problem if you say no? We not tried. If no response from your side, then that is useless. This live lecture will be useless. Priyanka Vaidya, Samanta Aishwarya, unmute yourself.
Yes, ma'am.
उत्तर द्या ना, मी विचारते, प्रश्न विचारते तर त्याला उत्तर द्यायचं गरज नाही वाटत का? मी काय म्हणते का तुम्ही ते सॉल्व केलंच पाहिजे असं?
ट्राय केलं मॅम पण येत नाही आन्सर.
मग हेच आन्सर तुम्ही पहिले दिलं तर काय प्रॉब्लेम आहे? मी तीनदा तेच विचारते ना, वेदर यू गॉट इट नाही तर नाही म्हणायचं, त्यात काय प्रॉब्लेम आहे? मी करून देते ना. तुम्ही कोणी रिप्लाय देत नाही. लाईव्ह लेक्चर होतं का असं? म्हणजे त्याचा काय उपयोग आहे लाईव्ह लेक्चरचा? Okay, so can you see the screen now? Phi inverse of t. Determinant of phi t is okay?
Yes, ma'am. Yes, sir.
Now we will find adjoint of phi t. And then 1 upon determinant of phi t, and we will do that one. So let me add new page. So first we will complete this yesterday's one. Then we will go to Floquet system. Where is that? Let me erase this. Okay, so determinant of phi t we have calculated. Now we will find what is adjoint of phi t. So adjoint of phi t, what is adjoint of phi t? It is m11, m21, m12, m22, right? So let me write here. Where is that phi t? Phi t is here. Shall I do from here? It's okay. So what is M1? Let me, what's this is? What is M11? M11 is minor of first, this one. So it is minus 1 raised to t plus 1. So for this, what is M21? M21 means cofactor of this one. Cofactor of this one is minus 1 raised to t, right? And it is minus. M12 is minus cofactor of, where is M21? Cofactor of this, right? What is this one? M12. M12 is cofactor minus times cofactor of A12, right? So what is A12? A12 is this one, minus 1 raised to t. Cofactor is minus 2 raised to, so minus of minus 2 raised to t plus 1. And cofactor of this one is minus 2 raised to t. Is that okay? This is adjoint of phi t.
Yes, ma'am.
Yes, ma'am.
Okay. Now, what we will do, let me, so adjoint of phi t we will simplify first, which is equal to or directly we can write now. What is that? What we want to calculate now? Phi inverse of t. So now phi inverse of t, then we will simplify it. Okay. Phi inverse of t is 1 upon determinant of phi t into adjoint of phi t. What is my determinant? 1 upon minus 1 raised to t, 2 raised to t, that is my determinant. And what is my adjoint? The adjoint is this one, minus 1 raised to t plus 1 minus 1 raised to t minus 2 raised to t plus 1 minus 2 raised to t. Now we will simplify this. Now from this I can take minus 1 raised to t common. So minus 1 raised to t plus 1 I can take from my, where is this, that? From R1. What is R1? First row. Minus 1 raised to t I can take common. Can you take?
Yes.
Can I take common? Yes. So minus 1 raised to t, if I take common from, I will write here, taking minus 1 raised to t common from R1. So if I take minus 1 raised to t common from R1, what I will get? What will remain? Minus 1 is remaining. Then here
Minus
also
1.
minus 1 is remaining. Or I can take minus 1 raised to t plus, okay, not, okay. Now from here, this will be as it is. From R2, I can take 2 raised to t common, or we can leave it. We will keep as it is. Minus 1 minus minus 2 raised to t plus 1 minus 2 raised to t. Step by step we will go. So now minus 1 raised to t minus 1 raised to t get cancelled. 1 upon 2 raised to t is this same. Minus 1 minus 1 minus 2 raised to t plus 1 minus 2 raised to t. Yes. So what will remain here? Minus 1 minus 2 raised to t plus 1 minus 2 raised to t. Now again minus I can take common from C1, taking minus 1 common from column 1 C1. So what I will get? Minus 1 upon 2 raised to t 1 minus 1 minus 2 raised to t plus 1 minus 2 raised to t. Is that okay? Is that okay? I just taken minus common from column 1. Okay. Now I take common, taking common minus 1 raised to t common from row 2. What I will get? Minus of minus 1 raised to t 2 raised to t as it is. So from R2 we are taking, so R1 will be as it is. If I take minus 1 raised to t common from R2, what will remain here?
2 raised to t plus 1.
2 raised to t plus 1. This minus 2 raised to t plus 1 I can write this minus 2 raised to t plus 1. How I can write? Minus 1 raised to t plus 1 and 2 raised to t plus 1, right? Is that right? Is the same, and I am taking minus 1 raised to t common. So what will remain? Minus 2 times minus 2 raised to t plus 1, right?
Yes.
And from here minus 1 raised to t I am taking, so 2 raised to t, right? So now again take minus 1 common from C1. C1 if I take C1, I will get from C1. So this minus minus will become plus, right? Minus minus will become plus. Minus 1 raised to t upon 2 raised to t minus 1. This will be 2 raised to t plus 1 minus 1 and 2 raised to t. Is that okay? So that is my phi inverse of t, and that only we want. Is that okay? And so I will erase this plus sign. Now it is okay. This is my required phi inverse of t. Is that okay?
Yes, ma'am.
Yes, ma'am.
Now we will substitute this value in variation of parameter formula. Now substituting values of phi t and phi inverse of t in variation of parameter formula, we get, what is my variation of parameter formula? This is my variation of parameter formula, right? So let me copy. Which is equal to, so now I can write this as phi t. I can take common here from here, phi t. What will remain here? Phi inverse of t0 u0 plus summation s is equal to t0 to t minus 1 phi inverse of s plus 1 f of s. Now I will substitute here. What is my phi t? Phi t is minus 1 raised to t upon 2 raised to t minus 1 minus 1 2 raised to t plus 1 and 2 raised to t. That is phi inverse, no? Phi t is different. What is phi t? This one. That is my phi t. Now what is phi inverse of t? Phi inverse at t0. Okay, we have to find phi inverse of t0 also. So what is phi inverse of t0? What is t0? T0 is given to be 0, right? U at t0. So my initial point is 0, right? So phi inverse at t0. Phi inverse of t0, if I calculate, what I will get? Here itself I can write phi inverse of t. This implies phi inverse of 0 is what? Minus 1 raised to 0 upon 2 raised to 0 means 1 minus 1 minus 1 2 raised to 0 plus 1 means 2 and 2 raised to 0. What I will get here? This is 1, this is 1, minus 1, 2 and 1, right? Is that right? This is my phi inverse of 0.
Yes, ma'am.
So phi inverse of 0. What is that? Minus 1, 2, 1. And what is u0? U0 is 1, 1. Right?
Yes.
U0 is 1, 1 plus summation s is equal to t0 to, no? So 0 to t minus 1. What is that? Phi inverse of s plus 1. What is phi inverse of s plus 1 now? So wherever t is there, we have to substitute s plus 1. Phi inverse of s plus 1. Phi inverse. What is phi inverse? minus 1 raised to s plus 1 upon 2 raised to s plus 1 minus 1 minus 1 2 raised to s plus 2 2 raised to t is replaced by s plus 1. That is my phi inverse of s plus 1. And what is f of s is given? F of s is this one. This is my f of t, right? This is my u at 0. This is my a of t. So what is f of s? 2 by 3 raised to s 1 minus 2. What is 2 by 3 raised to s and 1 minus 2. Is that okay? I just substituted the values in this. Is that okay?
Yes, ma'am.
Now if we simplify, this we will keep as it is first. Minus 1 raised to t, 2 raised to t, 1. T 1 minus 2 raised to t plus 1 minus 1. What will be here? If this is matrix multiplication. Minus 1, minus 1. What will be there? Minus 2. 2 and plus 1 means 2 plus 1 is 3. Is that right? First row, first column, right? Minus 1, minus 1. So minus 2. And here second row, first column will be 3. Is that right?
Yes, ma'am.
And plus summation s is equal to 0 to t minus 1. Now 2 raised to s, here 2 raised to s. So this 2 raised to s and this 2 raised to s will get cancelled. So 1 by 2 minus 1 raised to s plus 1 divided by 3 times 2 times 3 raised to s. Is that okay? And then minus 1 I have to take this as product. So what is the product? Minus 1 into minus 1 plus 2. So 1, right? Minus 1 plus 2. And here second will be 2 raised to s plus 2 plus minus 2 into 2 raised to s plus 1. Is that okay? Is that okay? I just simplify this. Now if you simplify this sum, this we will keep as it is, minus 2 plus 2 3 as it is, plus now summation s is equal to 0 to t minus 1. Now s is equal to 0. What will happen here? Then s is equal to 1, s is equal to 2, and up to t minus 1 we have to take this. So what is the summation of this? Or we can keep as it is also, no problem. So ut will be this one. In terms of summation, that will be my final ut. I'll just cut and paste this. So now we will go to the Floquet system definition, new definition. Floquet system. The equation, the system the system 4.16. What is my 4.16? It is u at the system u at t plus 1 is equal to a of t homogeneous one. A of t, u of t is called a Floquet system if A of t is periodic with minimum period p. What is this? This 4 point, the equation or the system given by 4.16, this one is called as Floquet system if this A of t is periodic. What is mean by periodic? What is mean by periodic? For example, periodic means after some time we will get the same thing, A of t only. So A of t raised to p will be A of t. Then we will say A of t is periodic with period p, right? For example, you add t plus 1 is equal to minus 1 raised to t into u of t, where what is A of t? Here A of t is minus 1 raised to t. And what is the period of this A of t? What is the period of A of t, which is periodic with period 2? What is the minimum period? Right? Which is the periodic with period 2, minus 1 raised to t. It will repeat that same value will be same after second period, right? Minus 1 raised to t is a periodic function with period 2. Therefore, this system is called as Floquet system. Now, before going to application of Floquet system or solving Floquet system, we will require one lemma. If C is a non-singular matrix, and P is a positive integer, then there exists a non-singular matrix B such that B raised to P is equal to C. What this lemma says that if C is a non-singular matrix and P is a positive integer, then there exists a non-singular matrix B such that B raised to P is equal to C. So we will prove this. So we won't prove for general n by n, but we will prove this theorem for 2 by 2 case. So already in theorem 4.8 we have obtained the real canonical form of matrix, right? In earlier fundamental matrices, where it is. Where is 4.8? What is that theorem? Yeah, that is in this one, theorem 4.8. Can you see this? Theorem 4.8. Let A be a 2 by 2 real matrix. Then there is a non-singular real matrix P, so that A is equal to Pj P inverse, where if A has real eigenvalues, not necessarily distinct, then its real Jordan canonical form will be lambda 1 0 0 lambda 2, and if A has a single eigenvalue, then J will be this lambda 1 0 lambda, and if A has complex eigenvalues, then alpha beta minus beta alpha. Is that okay? This already proved. So by theorem, I'll copy this. Theorem, recall the theorem. This is my theorem. So from theorem 4.8, I will have real Jordan canonical form in both the cases. When J has real eigenvalues, not necessarily distinct, it will have like this lambda 1 0 0 lambda 2, and if single eigenvalue with single independent eigenvector, then lambda 1 0 lambda. So in any case, so from theorem, four point 8, we will have real canonical form of a matrix. If the eigenvalues are complex, then we can show as in case of real eigenvalue, distinct real eigenvalue. That there is a non-singular matrix Q such that or so that C is equal to Q inverse JQ. Is the same. Is the same. C is equal to, instead of P we are saying it is Q, J Q inverse from this theorem. Is that okay? If A is any 2 by 2 real matrix, then there exists a non-singular matrix Q so that C is equal to QJ Q inverse. So this A, B, C are for different eigenvalues. What will be the form of that J? So in general case we can write as C is equal to, if my C is 2 by 2 real matrix, right? If C is a non-singular matrix and P is a positive integer, then we have to show that B raised to P is equal to C. So we are considering C is equal to Q inverse J Q. Is that okay? So where what is my J? J is lambda 1 0 0 so distinct eigenvalues, then lambda 2, where lambda 1 comma lambda 2 are distinct eigenvalues of C. Now if J is of the above form, with either real or complex eigenvalues, with either real or complex eigenvalues, we want to find a matrix B such that B raised to P is equal to C. Now, so what is B raised to P? Is equal to C. But what is my C? Q inverse JQ. Q inverse JQ. Q inverse JQ. So can I write Q B raised to P Q inverse will be what? Pre and post multiplying by Q and Q inverse. What I will get here? Q inverse J Q inverse. So what will be this? Just J. So this implies Q B raised to P Q inverse is nothing but J. Is that okay? Is that okay? This implies.
Okay, ma'am. Okay, ma'am.
This implies Q P raised to P Q inverse. If I multiply this, I can write this as QB Q inverse raised to P. Can I write? J will be as it is. What is Q? Since QB Q inverse raised to P, what will be this? QB Q inverse, QB Q inverse, QB Q inverse, and so on. QB Q inverse. This is P times. Okay, this all P times. So what I will get here? This Q inverse Q will be identity. So B square. Then again Q inverse will be identity. So B cube, and so on. So how many times B will be there? How many times B will be there? P times, right? And this will be as it is. So this Q B raised to P Q inverse I can write as Q B Q inverse raised to P. Same thing I have written here. So now we choose now we find we choose B so that QB Q inverse is equal to, so J raised to 1 by P. What is J? J is my lambda 1 0 0 lambda 2 and raised to 1 by P. So I can write this as lambda 1 raised to 1 by P 0 0 lambda 2 raised to 1 by P. That is my QB Q inverse. So what can I write? So this what will imply? B is equal to Q inverse, this as it is J, lambda 1 raised to 1 by P 0 0 lambda 2 raised to 1 by P and Q. Can I write this? Q inverse Q B Q inverse Q is nothing but my Q inverse by P 0 0 lambda 2 raised to 1 by P and Q. Is that right? So Q inverse Q will be identity. So that is B is equal to this. Is that right? Is that right?
Yes, ma'am. Yes, ma'am.
So for this, such B exists. So for every C, where is it? If C is a non-singular matrix, then we can choose that B so that B raised to P will be C. Now if we consider the case finally when J is equal to lambda 1 1 0 lambda 1, then what should be my B? So repeating the same steps again, applying same steps, we get Q B Q inverse raised to P will be J. But now we want to find the B of the form B is equal to what I want? Q inverse this Q inverse J raised to 1 by P. J raised to, like that we want. So what is J raised to 1 by P? So to find J raised to 1 by P, what is my J? Lambda 1, 1, 0, lambda 1 and raised to 1 by P. So which is equal to say which is equal to say lambda 1 raised to 1 by P, A 0, lambda 1 raised to 1 by P. Now we want to find this A, so that I will get this. Okay. So to find A, for which we will get this. Earlier it was diagonal matrix, so directly we have written lambda 1 raised to 1 by P, 0, 0, lambda 2 raised to 1 by P. But here we cannot find, we cannot take directly raised to 1 by P because here 1 is there. Right? So due to this we will get here A. So we want to find that what should be that A. So for that, consider lambda 1, 1, 0, lambda 1. So lambda 1 raised to 1 by P, A 0, lambda 1 raised to 1 by P and raised to P. This I can write now. Pth power of matrix. How we can find? If we use binomial formula. So for using binomial formula, we will write in some addition form. A plus B raised to P we can write. So lambda 1 raised to 1 by P identity matrix plus 0 A 0 0. We will simplify this and we will write this. Can I write like this? Can I write like this? Now this we have splitted into lambda 1 raised to 1 by P identity matrix 2 by 2 plus this. Is that right? Now using binomial formula. Lambda 1 raised to lambda 1 raised to 1 by P raised to into I raised to P. So identity raised to P is identity only, and lambda 1 raised to 1 by P raised to P will be lambda 1 I plus P times lambda 1 raised to 1 minus 1 by P 0 A 0 0. Then second one will be, what is P minus 1 by 2 lambda 1 raised to 1 minus this will decrease, right, 2 by P, and this for this square, but square of this triangular matrix will be 0. So remaining all will be 0 0 0. We will get here 0 matrix. Why 0? Since 0 A 0 0 square is 0. Similarly, 0a 0 0 cube is also 0. Is that right? So we will get here 0. So which is equal to lambda 1 a p lambda 1 raised to p minus 1 by p and 0 lambda 1. So that will be my matrix. Which matrix? This one, J. So we want to choose A so that A P lambda 1 raised to P minus 1 by P should be 1, right? So what should be my A? A will be 1 by P lambda 1 raised to 1 by P minus 1. Therefore, B required B of the form Q inverse lambda 1 raised to 1 by P. A is my 1 by P lambda 1 raised to 1 by P minus 1, 0 lambda 1 raised to 1 by P times Q. So in any case we are getting B which satisfies B raised to P is equal to C. So this proves the theorem. Is that okay? So we can stop here.